Dear friends of the sun, have you ever wondered if we could one day live on Mars? Then grab a tea, coffee, or a milkshake of your choice. Get comfortable, and let's explore how a Mars colony could become a reality. For centuries, people have dreamed of visiting the Red Planet, and even settling there one day. But only in the last few decades, thanks to modern space technology and ambitious plans from space agencies and private companies, has this dream moved closer to reality. In this comprehensive video, we will explore the opportunities and challenges of Mars colonization, from scientific and technological hurdles to the ethical and societal questions this mission raises. Why Mars? Geographical and physical conditions. Compared to other celestial bodies in the solar system, Mars offers several key advantages for potential colonization. It is the most Earth-like planet, with a day length, Mars day or sol, of 24.6 hours, making it easier to adapt to the human circadian rhythm. Additionally, it has a solid surface, making it more attractive for settlement compared to gas planets, like Jupiter or Saturn. Distance to Earth. Mars is, on average, about 225 million kilometers from Earth. While this distance seems vast, it is relatively close within the solar system, especially compared to the outer planets like Neptune or Uranus. With modern technology, a trip to Mars could take between 6 and 9 months, depending on the position of the planets. Scientific potential. Mars also offers invaluable scientific opportunities. Exploring its geology, potential water reserves, and climate could help us learn more about the past of the solar system. Some researchers even speculate that primitive life forms once existed on Mars, or may still exist, making the search for evidence of extraterrestrial life extremely exciting. Technological challenges. Despite these advantages, colonizing Mars brings immense technical challenges that must be overcome. The planet poses extreme demands on human technology and survival in a hostile environment. Propulsion technologies and transport. One of the biggest hurdles is transport to Mars. Rocket propulsion, as we know it today, is slow and requires a vast amount of fuel. Companies like SpaceX are working on developing reusable rockets and more efficient engines to reduce the cost and effort of Mars missions. A possible future technology is nuclear propulsion, which could significantly shorten travel time and be more efficient than chemical propulsion. Ionic propulsion, or the use of solar sails, is also being considered to reduce travel time and energy requirements. Life support systems. Mars' atmosphere consists of 95% carbon dioxide and is uninhabitable for humans. Additionally, it is extremely thin, with only about 1% of Earth's atmospheric pressure, meaning that closed habitats or spacesuits would be needed to survive. Oxygen would either need to be brought from Earth or produced locally. One approach to oxygen production on Mars is the MOXIE technology, Mars Oxygen In Situ Resource Utilization Experiment, which is already being tested in an experiment on Mars. Moreover, the low gravity, about 38% of Earth's gravity, presents a challenge. The long-term effects on the human body, particularly muscles and bones, are still not well understood. Artificial gravity systems may be necessary to counteract the negative health effects. Protection from radiation. On Earth, the magnetic field and dense atmosphere protect us from deadly cosmic radiation and solar wind particles. Mars, however, has no strong magnetic field, and its thin atmosphere offers minimal protection. Astronauts on their way to Mars and future colonists would thus be exposed to significant radiation, leading to cancer, tissue damage, and other health problems. One possible solution could be the construction of underground habitats or protective domes made of radiation-repelling materials. The use of Mars soil, regolith, as a natural shield is also a viable option. Challenges in resource acquisition. A sustainable colony on Mars would have to rely on locally available resources and minimize logistical support from Earth. The ability to use local resources, known as in situ resource utilization, ISRU, will be crucial. Water extraction. Water is one of the most critical resources for survival on Mars. The good news is that Mars has water ice deposits, especially at the poles and possibly beneath the surface. However, this water must first be extracted and processed before it can be used by humans. Modern technologies, such as electrolysis, could split water into oxygen and hydrogen, which would not only provide breathable air, but also fuel for the return journey to Earth. Food production. Transporting food to Mars for a permanent colony is not practical. Colonists would need to produce their own food on site. This could be done by growing plants in specialized hydroponic or aeroponic systems, where plants are grown without soil, using nutrient solutions or mist systems. Mars' atmosphere and soil are unsuitable for direct cultivation, but researchers have used simulated Mars soil on Earth to test whether it can be modified for plant growth. Advances in genetic engineering could also help develop plants specifically adapted to Martian conditions. Societal and ethical challenges. Beyond technological hurdles, colonizing Mars raises a series of ethical, social, and legal questions. Ethical considerations. One of the most pressing ethical issues involves planetary protection. Mars may, as mentioned earlier, harbor microbial life, or may have done so in the past. Human activities could contaminate or even eradicate this potential life. The question arises, do we have the right to colonize another planet without knowing the consequences for possible native life forms? Social and political questions. Another challenge is the question of political control. Who owns Mars? According to the Outer Space Treaty of 1967, no state can claim Mars or any other celestial body. But how will this work in practice when private companies like SpaceX or Blue Origin actually establish colonies on Mars? Will new international agreements be necessary? The issue of equality will also be a topic. Who will have the right to live on Mars? Will it be reserved only for the wealthy and powerful? And how can we build an interplanetary society that is more just and inclusive? Opportunities and future visions. Despite all the challenges, colonizing Mars offers enormous opportunities. Advancements in science and technology. Colonizing Mars could drive groundbreaking scientific and technological advancements that would benefit not only Mars but also Earth. Technologies for water purification, food production, and energy generation could improve resource management on our home planet and lead to a more sustainable lifestyle. Survival of humanity. Many experts see Mars colonization as a necessary step for the long-term survival of humanity. The famous astrophysicist Stephen Hawking warned that humanity might need to find a second home in space within the next few centuries to escape disasters on Earth. Whether due to environmental destruction, nuclear wars, or asteroid impacts. Conclusion: Mars as our next home. Colonizing Mars is one of the greatest challenges humanity has ever faced. It requires groundbreaking technological innovations, substantial financial investments, and overcoming ethical and social hurdles. Yet, it offers the unique opportunity to take the next major step in humanity's evolution, from a solely planetary species to an interplanetary one. What do you think? Will we be able to live on Mars one day? And what kind of life will it be? Hard work or a relaxed lifestyle? Let me know in the comments.